Next, we have Mr. Bruce Templeton, and he's the founder and CEO of NetForScale.
Thank you. It's an honor to be here today. It's a pleasure to speak to you. Everybody coming out on a Saturday, I'm impressed. Talking about cloud computing. He announced me as the founder of NetForScale, but I wanted to embarrass our CTO, but Telemachus Lou in the back corner here standing up. He's a co-founder of the company with me. So he's the scientist behind all of this wonderful stuff that we're doing. So NetForScale, I'm going to get a little technical here. We're a smaller company. We're not the size of Salesforce or Huawei. We compete with Amazon, so you might think we're in over our heads, but we like to say there's riches in the niches. So there's things that we do that Amazon doesn't do and probably they don't want to do. So this is working out very well for us. What I'm going to do is start off, and there's also some disputes on the panel, I'm sure, about what cloud really is, and I could probably get into it with the gentleman from Huawei about this too. He made a lot of great points. We have our own feeling about this. I think Amazon does too, with respect to software as a service, PaaS, and infrastructure as a service. So I'm going to talk about that a little bit today. But cloud computing is one of these things where it's a little bit like religion sometimes, where the discussion could go on for a very long time, and there'll be lots of disputes. And even then, there might not be a lot of agreement after you're done. The one thing I think everybody's in agreement with, though, is the internet is very powerful, it's changing our lives, and it's very, very exciting to be part of this. So just a little bit of the history of cloud computing. So in 1969, this was ARPANET that I talked about here, the connection between the engineering lab at UCLA and SRI in Menlo Park. It was made possible by a technology called packet switching. It was developed by a gentleman named Mr. Davies out of the UK, and there was also some work that came out of the RAND Corporation in trying to figure out how to build systems that could withstand nuclear attacks, which started in the late 50s, early 60s. Then the National Science Foundation started CSNet in 1981. It was the Computer Science Network. And in 1986, the National Science Foundation created their own net. And it really started to take off at this point. That was a T1 backbone. The next year, in 1987, IBM, MCI, and also a group called Merit out of Michigan State University created a T3 backbone. And that was, in 1987, was the very first privately owned internet backbone, if you will. Boy, did things change quickly. Of course, companies came along to develop technologies that would allow this to take off. Mr. Berners-Lee on a NeXT computer developed the first browser in the late 80s. And of course, Netscape came along and things were never the same, right? So in 1995, it fully privatized, meaning that ARPANET had been shut down in the late 80s, and finally NSFNet was shut down in 1995, and the internet was now officially privatized. So what made this possible? Well, I talked about packet switching. The governments, the universities coming together, trying to make this happen. The integrated circuit, Intel, AMD, so trying to drive the price down on integrated circuits really made a big difference. Then, of course, Apple, the first computer, IBM, for the first PC, and then PC operating systems, so Microsoft and Linux. Then computer networking with companies like Robert Metcalfe developing up at Xerox PARC in Palo Alto here, Ethernet technology. And tying that together with, it was actually Bridge Communications that shipped the first router, but Cisco is really famous for developing the first routers in volume. Then e-commerce. So in 1985, Jeff Bezos with Amazon started shipping books. Then the next step in the late 90s, and there's some disputes on this, APIs have been around really a long time up to that point, but they really started to take root in the late 80s and really made things like SaaS and Salesforce possible. Because now you could automate a lot of the software and the interactions between different platforms, so you could create this cross-platform communication and start to automate things. And that really changed everything, because you could go in and have a subscription-based model, web-accessible software that didn't have to ship on a CD-ROM. And in the back, you didn't know it, but a lot of things were taking place when you made a command or set up an account. They had they could have a very complex set of platforms in the back end, and you had no idea. And that really changed things from a user experience. Virtualization, as we know it today with the hypervisors, I think it was really started with the zone technology in Sun in the late 90s. And then VMware, of course, a lot of people know about VMware, and they really took it to the enterprise. And of course, there's Citrix Zen and Red Hat KVM. So we use Red Hat KVM for the basis for our cloud. The next thing is software-defined networking in OpenFlow. So probably the two largest implementations of OpenFlow on the planet are Google and Facebook. So infrastructure as a service, PaaS, SaaS, what is it? Well, so infrastructure as a service, we like to say we sell picks and shovels to miners. So for California with the gold rush, a lot of people know through history that the people that really made the money during the gold rush were the ones that sold the picks and shovels. A lot of the miners went broke and went home. So that's what we do. When we go into a room full of developers and startups and even enterprises, almost every single company in that room can use our service. Now, you could say that every company in the room could use Salesforce, but the reality is that not that Salesforce would run on our platform, because that would be a pretty big account for us to get. They do their own thing. But in theory, same page, Salesforce, any other company delivering a SaaS solution could run on our platform. So this is where the dispute comes in. I was one of the early employees at a company by the name of Foundry Networks in the late 90s. Before that, I worked at Cisco, Pay Networks. So I've been around networking for some time. And I was selling equipment and helping build networks for a lot of these ASPs that went defunct when the bubble burst. So SaaS, for instance, Salesforce, that was possible with the technology that was available then. So my question is why is that cloud now? I'm not going to fight this one. It is cloud. This is the way it goes. But our view of it is that what really changed is virtualization came along. You tied it in together with all the things on this list. And finally, starting in about 2005, 2006, you could take commodity hardware, intelligent software, all the technologies on this list, and start to tie them together and offer something like what Amazon did. So we compete directly with Amazon on that level. So PaaS, for instance, can run on our platform also. So both SaaS and PaaS can be our customers. We're kind of the plumbing. When your plumbing's broken in your house, you care. Otherwise, a lot of people aren't as interested in talking about what we do, but it is important. So I don't have as many graphics as some of the other presentations here, so I'm just going to move through, and it's a little bit technical, but I just want to share with you our view of infrastructure as a service, what it is, and where it's going, and what some of the challenges are with it today. So infrastructure as a service, the idea behind it is that, and with most cloud, it's pay as you go, and it's resources on demand. So what we're offering is the picks and shovels, the compute and the storage on demand, and you should be able to programmatically control it, and it should be utility-based pricing model where you pay for what you use and no more. So things like that could be object-based storage, which is like Amazon's S3, or what we call ours is called Object Store. You can grab OS images, configuration templates, load balancers, IP addresses, DNS, CDN, packet software, networking. So these are all the elements that an enterprise or a small startup would use to try to build their SaaS solution, or even to introduce a PaaS solution based on our platform. These are the building blocks. So what does it do? It allows you to reduce 24/7 staffing costs, you eliminate co-location costs and hardware costs, and you can geographically distribute your resources around the planet for different purposes, for disaster recovery or for better user experience. And what it's doing is this is truly disruptive, all these technologies coming together. It's really amazing to watch, and the possibilities, as you had mentioned earlier about what's coming, this is really opening things up. Meaning that you could be in a Starbucks with a few developers and you could start a company and you can get in and compete against a large company very quickly without having to buy any equipment. You don't need filing cabinets anymore in theory. So you can use SaaS platforms like Salesforce or NetSuite or something to run your accounting, or Intuit payroll. You don't have to have filing cabinets. It's all saved in the cloud. The other thing you can do is you can spin up infrastructure. That's what we like to say is spin it up. So you can go in and create servers You can create storage, and you can start to run that SaaS application without having to go out and run cables or hire people to run it, and we will provide the 24/7 support for it. That right there, the time to market, the reduced investment is just so disruptive to business today. It's allowing companies all over the world to get started on much less money, much fewer people, far fewer people, and much quicker. So this is the technical piece, and I'll try to get through this quickly, so I'm running out of time here, but a lot of folks have gone into the cloud, technical people trying to develop databases, do a lot of big data processing, and they're running into problems with the virtual servers. And so then they end up having to shard their databases when the servers can't handle it, and they have to move and try to distribute it. Things can get rather complicated. And what we feel about this is that dedicated servers still have a place. So we found, we want to develop a cloud where you could go in and automatically create virtual servers or hardware-based, or I'm sorry, bare metal servers, where you're single tenant, you're the only one on there, and there's no hypervisor loaded. So you're getting a pure access to the hardware. So what we tried to do is we have made taken the first step towards developing our own software-defined networking technology as we wait for some of the open flow technologies and some of the other things to come along. And we had to do this because we wanted to be able to, virtual and dedicated are always on separate networks, and this is one of the reasons Amazon doesn't do it, is we wanted to be able to develop technology where the customer could go in on their own, user control, create their own network, and bring it together, the virtual and the dedicated together to get the maximum performance. The last one here is programmable infrastructure is too complicated for many users. So we love it when people come in and program against the API, but the reality is that there will always be two camps. So I'll just quickly go through this. So the hybrid compute model I mentioned is important. Solid state drives is that's a technology that's coming along and improving every day that's really helping out with performance. Network technology where you can start to join things together and the user can control their network through the API and distribute it globally. 10 gigabits per second and some of the InfiniBand technology is also an option to try to get the speed up. And then there's the graphical user interface API, and what we build is a build language for the cloud called CloudScript, which allows developers to test and debug their code using a built-in IDE. So the concept here is infrastructure is code. It's now a software development activity, and you should be able to scale a global network from a Starbucks. So the future of cloud computing, we think that both dedicated and virtual are needed for the foreseeable future. We do think eventually that virtual servers will nearly match bare metal dedicated, but there's a lot of companies working on this, and it's going to take, whether it be the chip manufacturers building systems, the hypervisor developers, they're all going to have to come together to try to solve this problem. SDN, we're just scratching the surface on what's possible with that, so we're very excited about what that holds for the future. And PaaS and infrastructure as a service we think will always coexist because they're both required for their own reasons. PaaS, I'll just touch on that a little bit, is oftentimes people ask us, why should I go to Google App Engine or some of the other Heroku owned by Salesforce? And that, oftentimes we say, is a great solution. It's easy to use, it expands contracts automatically for you. But one of the problems we're also finding, just like with the dedicated bare metal servers, is some of our sophisticated clients, they like the ease of use of a Heroku, for instance, but they don't want to be locked out from the information if things go wrong. So I'm just going to move through this quickly here. I'm out of time. So the idea is the enterprise has not really hit the cloud yet, the infrastructure as a service. Amazon's really trying to start going after them. When we see that happen, I think you're also going to see a lot more R&D spending on infrastructure as a service. And the possibilities are quite interesting when that happens, because we're out of several trillion a year in IT spend. Public cloud is still less than $10 billion a year. You can just see how it's just scratching the surface. We're just starting on this. So thank you very much. That's it.